Technology underpins the world we live in today. We carry all of our contacts, our music, our movies, and now our wallets in a device small enough to fit in a trouser pocket. In a couple of years, nearly all smartphones will have NFC capabilities, and 1 in 3 people will be using one. This poses a significant problem to all major banks worldwide. While the way we pay for things has evolved, the underlying network topology remains the same. Our transaction starts off at the place the purchase was made. From here, the data travels over the internet to the gateway server via a payment processor such as MasterCard or Visa, and then on to one of the bank's mainframe computers to be processed. At the edge of network, the gateway server connects the bank's private network to the largely untrusted public internet.
So, I mean, failures, I suppose, can be separated into kind of like fault of the users,
Yes.
including us, and technical problems where something fails. So, obviously, we try our best to mitigate against technical faults through redundancy at hardware layer. So, whether that means multiple connections to switches or multiple places to store the data, either within the same server or in a different place.
Being situated at the edge of network means that all transaction data will have to flow through the gateway before being processed. The gateway is needed to act as a buffer to make sure that the load on the bank's systems does not overwhelm them. Duplicated or missing transactions due to a system's failure could cause absolute chaos for consumers and businesses alike. With substantial losses, the share price of a business could plummet, and if the stock market dropped by too many points, then it might well crash. The key to solving this problem is using technology which has already existed for a long time, but in a new and novel way.
So this is where RAID comes in, and this is an example of RAID 1, where you get 2 disks, you connect them up together, and they both store exactly the same thing. So if you've got a file on here, you've got a file on here as well. So if one of them fails, you just use the other one and replace it. So you have a backup. Now, obviously, that's just RAID 1. Most people use RAID 5 or 6, which need at least 3 or 4 drives. Software failure is another pretty big problem that we all run into sooner or later. And the main way we can get around this is using VMs or virtual machines. Essentially what a virtual machine does is it splits a physical machine up into many smaller machines, each doing the same thing. And say you have a transaction system, you can have a single server split into many virtual machines that each process a transaction at the same time. It's all run by a hypervisor that checks the status of each machine. And say a virtual machine goes down because of a software bug, like that, suddenly you've lost one processing thread. The hypervisor will see this and it will redirect all the transactions to the other 2 machines, thus meaning all your data is safe and everything goes through the system as normal.
Technically, SSSDs are, there's no moving parts. It is just basically chip storage. Okay, so controllers can run faster. You can just literally get data in and out far quicker.
Solid-state drives are another new technology that can be used to protect the transactions passing through the gateway. They have no moving parts and use flash memory for storage, and this makes reading and writing from them near instantaneous and makes them a great solution for handling large amounts of data per second. RAM is a special case because no matter how much RAM there is, if the power goes down, then it simply won't work. And this is why mission-critical servers use non-volatile RAM. Each NV RAM module contains non-volatile flash memory and an ultracapacitor. When the power to the server is lost, the NV RAM module detects this and copies the data from the RAM chips to the flash memory. This creates a full, secure backup of everything that was in the server RAM, which can be stored until the server is running again. The future success or failure of contactless payments will depend on how the technology behind the scenes performs. It's clear that the main problem will always be how the vast amount of transaction data is buffered and secured. The technology to handle this challenge exists, but must be implemented in new and innovative ways if we are ever to live in a truly contactless world.